Many of you may already be familiar with pH and how it's related to acids. Um, pH is what some people find hard to understand and some people find very easy. Just realize it's as simple as this. You put a P in front of something, that means you take a negative log of it. So pH means negative log of proton concentration. pOH means negative log of hydroxide concentration. Log actually tells you what the exponent is on a 10 to a power. So log of 10 to the 5 is 5. Log of 10 to the minus 5 is 5. You notice there's a negative in front of this log. That's because proton concentrations usually are 10 to the minus some value. So if you take the log of a typical proton concentration, you'll get a negative number. And then what does this negative do? It changes it to a positive. In order to figure out what the proton concentration is at a particular pH, you just take 10 and raise it to the negative pH. So let's go ahead and look at an example. If my proton concentration is 5 times 10 to the negative 4, all I have to do is take negative log of that number, and it gives me 3.23. So what is the pH of proton concentration, of a pH of a proton concentration of 4 times 10 to the minus 11? Go ahead and try this on your calculator and make sure you can do it. On some of you, you have to press log first and then enter the number. Remember to use the EE key and not a times 10 to the power unless you use parentheses. Some of you may have to enter your number first and then press log. And so the negative you can enter into your calculator with the log, or you can just get a negative number and then change it to a positive one. So if you have proton concentration is 4 times 10 to the minus 11, then the pH will be 10.4. To figure hydronium ion concentration from pH, you'll use this equation, that proton concentration or hydronium ion concentration is equal to 10 to the minus pH. So if the pH is 2.7, all I do is I raise 10 to the negative 2.7 and figure it on my calculator, which gives me 0.002. You go ahead and try to determine what is the proton concentration of a pH equals 8.8. Proton concentration, or hydronium ion concentration, is going to be equal to 1.5 times 10 to the minus 9. Here are some problems for you to try on your own. What is the pH of a solution with a proton concentration of 8 times 10 to the minus 9? And what is the hydronium ion concentration of a solution with a pH of 2.5? To determine the pH, you always look at proton concentration, never use hydroxide. You then enter this into your calculator as the negative log of that proton concentration. After doing your calculation, you'll get 8.09. To determine the proton concentration of a pH of 2.5, I just take 10 and raise it to negative 2.5, and it gives me 0.00316. The pH scale is important to know intimately, especially if you're going into nursing, because they will be using it and expecting you to know whether things are acidic and when pH changes, which direction proton concentration is going. Acidic pHs are below 7. Basic pHs are above 7. Neutral is exactly 7. If you have 7.1, it's not neutral anymore, that's basic. So, acidic has pHs of 1 to 6, or actually 1 to 6.9, and the concentrations of protons follow that same relationship. So if the proton concentration is greater than 10 to the minus 7, these numbers are greater than 10 to the minus 7, then what happens is you have an acidic solution and your pH will be below 7. The hydroxide tracks the opposite way because proton concentration times hydroxide concentration has to equal to 10 to the minus 14. So as your solution becomes more acidic, the pH drops, proton ion concentration increases, hydroxide ion decreases. With basic solutions, the higher the number, the more basic, the less acidic, of course. But basic solutions are anything above 7. The higher you go, the more basic. The concentrations of protons are getting very small as you go up in pH, and the concentration of hydroxide is increasing as you go up in pH. Keep in mind that as pH decreases, proton concentration increases and hydroxide ion concentration decreases. And as you go above 7, as you increase your pH, proton concentration decreases, hydroxide increases, and your pH increases because it's more basic. So below 7, acidic, the lower, the more acidic. Above 7, basic, the higher, the more basic. So what is the proton concentration, hydroxide concentration, and pH of a 3.61 times 10 to the minus 3 solution of sodium hydroxide? Well, to do this, we're going to be putting together everything that we've learned. This concentration, because we know sodium hydroxide dissociates, gives us sodium ion concentration and hydroxide ion concentration. We're going to be using the hydroxide ion concentration. That's what we are asked for here, but we also have to figure out what is the proton concentration. The proton concentration can be determined from our equation that proton concentration times hydroxide concentration is 1 times 10 to the minus 14. If I want to figure out what proton concentration is, I rearrange this so that proton concentration is equal to 1 times 10 to the minus 14 divided by hydroxide ion concentration. I then plug in my number here and I get 2.77 times 10 to the minus 12. This is the hydroxide concentration. This is my proton concentration, and now I need to determine my pH. What is pH equal to? pH is equal to the negative log of proton concentration. So I have to look up here. Do I take this number? No, I take this number because this is proton concentration. If I take the negative log of that, I've determined the pOH. So I plug it in and I get 11.6. That makes sense for a solution of sodium hydroxide. Because it is a base, it should have a high pH, which this is. So proton concentration is 2.77 times 10 to the minus 12. Hydroxide ion concentration is 3.61 times 10 to the minus 3. And your pH is 11.6. You go ahead and determine what is the proton concentration, hydroxide concentration, and pH of a 2.6 times 10 to the minus 5 solution of hydrobromic acid. First thing, write your dissociation equation. That gives you your concentrations of protons, of bromide also, but of protons. Your proton concentration will give you hydroxide concentration due to this equation. You rearrange it, hydroxide is equal to 1 times 10 to the minus 14 over proton concentration. You take your proton concentration and plug it in here. Oh, excuse me, plug it in here, and you get this value. Now we need to determine pH. Which concentration do I use? Do I use this or do I use this? Well, I look for what one is proton concentration. So here's proton concentration. pH equals negative log of proton concentration. I plug in the value of proton concentration and I get 4.59. Determine what is the proton concentration and hydroxide concentration of a 1 molar solution of sodium chloride. This one's a really quick, easy problem. If I look at sodium chloride, I'm putting sodium ions in solution and chloride ions in solution. So I have not added protons or hydroxide, so the concentration is not changing from pure water. The concentration of pure water is 10 to the minus 7 for hydronium ion, 10 to the minus 7 for hydroxide, and a pH of 7. So what is the proton concentration, hydroxide concentration, and pH of a 3.5 times 10 to the minus 4 solution of methanol? Be careful. This is not an ionic compound, is it? It's covalent. Covalent compounds don't dissociate. They dissolve in water by hydrogen bonding. So, it is not a hydroxide, nor is it an acid. So you're not adding protons or hydroxide to water, and the characteristics with regards to pH are going to be the same as pure water. So hydronium ion concentration, 10 to the minus 7. Hydroxide concentration, 10 to the minus 7, and pH of 7. What happens to pH, proton concentration, and hydroxide concentration when magnesium hydroxide is added to a sodium carbonate solution? Well, we don't have to worry about what pH is a sodium carbonate solution. We're just going to find out what happens when magnesium hydroxide is added. You see the hydroxide, so you know this is a base. So what happens when you add a base to water? Well, proton concentration goes up, proton concentration goes down, hydroxide concentration goes up, and your pH goes up. So just keep that in mind. When you add anything that's a hydroxide, you're adding base. Proton concentration goes down, hydroxide concentration goes up, and your pH increases also. What happens to the pH, proton concentration, and hydroxide concentration in your mouth when you drink Coke? Coke contains both carbonic acid and phosphoric acid. This is adding acid. When you add acid, pH goes down, proton concentration goes up, and hydroxide concentration goes down. What is the proton concentration, hydroxide concentration, and pH of a 2 times 10 to the minus 3 solution of potassium hydroxide? First, you have to write your dissociation equation, and you see that you're making hydroxide. Your hydroxide concentration is 0.002 molar. Now you need to figure your proton concentration. You take this equation and solve for proton concentration, and you get that it's equal to 10 to the minus 14 over hydroxide. You enter your hydroxide, and what you get? 5 times 10 to the minus 12. Now we're going to figure out our pH. What do I take the negative log of? What number do I use here? Do I use this one? Do I use this one? Do I use this one? Since it says pH, I look for proton concentration. This is proton concentration, so I take the negative log of it, and I get 11.3.